All right, let's get going. Good morning, everybody. Welcome to a sunny, wonderful morning of Chem 1211 with your host, me, Dr. White. And hopefully, I won't get kicked off again for my internet service. All right, today is going to be a real colorful lab. We'll get to that later. What I'd like to do first is go through problem or chapter 8 problem set. Don't forget, hand in your lab that's due today. Two of you, and I've got to email you. I couldn't open your lab. This morning I posted the lab scores from, I think it's lab 6. And one of the problems most people got wrong in lab 6 was with the coefficient at the bottom of the first page. Some of you just out and out forgot to do it. And the way I graded lab 6 was if you got everything right, you got 10 points. If you missed one or two things, you got 9. If you missed 3 or 4, you got 8. If you got 5 or more, I gave you 7. I was generous. And so, hold on, my glasses are dirty. Time out for a clean this lab. All right, now everything's better. And that's how I graded for the lab. So I just wanted to make you sure you understood that. And always feel free, come to my office hour or stay after class after lab. All right, let's do some quick review. And just to be on the safe side first thing in the morning, thumbs up, people. Do you see the equation? Thank you. I've got the fastest thumbs up group in the world. Thank you, and it really helps. Now, you should know at the base of the arrow, these are the reactants, which in this equation are hydrogen and oxygen. At the head of the arrow are the product or products. In this case, there it's water. Now, on problem on the lab with the balanced chemical equations, it says add the coefficients. That's the number in front. And what's the total? Well, most people, a lot of you got it wrong because you forgot when there's no number here, it's really the number 1. So the adding the coefficients for this reaction would be this, not 4, it would be 5. I'll never put that on a test, but it was something to remind you on the lab. Now, another thing that's very important for today's practice problem set are the coefficients are molar ratios. And what this really tells us, let me rewrite it again, is that you have 2 moles of hydrogen reacting with 1 mole of oxygen to make 2 moles of water. Again, this is probably one of the most powerful things besides the mole concept itself that I know in all of chemistry. 2 moles of hydrogen react with 1 mole of oxygen to make 2 moles of water. And once you know that, you can do some serious good. And I have. If you're using a fabric softener, well, guess who had a hand in it? Long ago, I worked in that industry. All right. And let's look how you use that. Everybody see the reaction on the page now? Thank you. All right. Let's look at chapter 8 problem set. By the way, I found a mistake I made here. Oh no, Dr. White, yes, I make mistakes. But anyways, you have C3H8, that's propane. That's the stuff you get in the white tanks for your barbecue. You're reacting with oxygen. We call this combustion. And it gives off CO2, carbon dioxide, water. Plus, you don't show in a balanced chemical equation, it also gives off heat. which is the flame you use to cook your hot dogs, hamburgers, steaks, or if you're vegetarian, if you've ever barbecued onions, broccoli, and a few other vegetables, those are good too. I'm not a vegetarian, but I like my vegetables. All right, so the question is, for the following balanced chemical reaction, how many moles of oxygen are needed to make 23.33 moles of CO2? And here, what are we trying to find? Moles of oxygen. What are we given? This number, moles of CO2. So this is the only place I can start with. If there was a ratio I could use, what would I want the units of my answer to be? Well, we figured it out right here, moles of oxygen. So whatever I'm trying to get to, what am I going to use? I'm going to use my good buddy, good friend, unit analysis. Love it. And it has been my good buddy. Hopefully, it's your good buddy and good friend too. And whatever I'm trying to get to, the units go on top of this ratio. Whatever I'm trying to get rid of, the units go below. Notice moles of CO2 divided by moles of CO2 cancel out, and I'm left with moles of oxygen, my answer. Where do I get these numbers? From the balanced chemical equation. Where do I find a relationship between oxygen moles and carbon dioxide, CO2 moles? Here, 5 moles of oxygen make 2 moles of CO2, 3 moles of CO2. I was looking at this number. Oops, let's look over here. Let's do that again. 5 moles of oxygen make 3 moles of CO2. And therefore, 3 moles of CO2 are made from 5 moles of oxygen. These are exact numbers. And here's my mistake. This is 4 significant figures. My answer should be 4. This really should be 38.88, not what I have there. And that's how you do it. Remember, the coefficients of a balanced chemical equation give you molar ratios. This reaction, 1 mole of propane, C3H8, react with 5 moles of oxygen to give 3 moles of CO2 and 4 moles of water. I'm in the sharing mood today, so I'm going to share and let you have some fun too. So everybody, let's look at the following. If we were in a classroom, you'd have to wait while I write this on the whiteboard, which is not named after me. Oh, that was an awful joke. And here's one for you. First of all, I'm giving you this balanced chemical equation. And the question is, and I'll translate it for you because a couple of students, my office hour, said, we have a hard time reading your handwriting. Sometimes I do too. How many moles ammonia, NH3, must you react to make 4.58 moles of nitrogen? And it's your turn. So ready, set, go. Remember, use your good buddy, your good friend, unit analysis. I'm looking at you all. No. Let's try, we're going to alternate between polling and non-polling and thumbs up. All right, I'll give you about another 20 seconds, and then we'll start working on the problem. All right, let's go ahead and work on the problem. And if it looks familiar, it's right here. And now, again, you're given this balanced chemical equation. How many moles of ammonia are needed to make 4.58 moles of nitrogen? Well, what are we trying to find? Moles of ammonia, NH3. What are we given? Moles of nitrogen. And therefore, this is all we have to start with. I want to get the moles of ammonia. I'll use my good buddy, my good friend, unit analysis, and hopefully yours too. And whatever I'm trying to get to goes on top of the ratio, moles of ammonia. Whatever I'm trying to get rid of, I don't want my answer, I'm going to put underneath the ratio, moles of nitrogen. Where do I get these numbers? From the balanced chemical equation. For every 4 moles of ammonia, I make 2 moles of nitrogen N2. Again, for every 4 moles of ammonia, I make 2 moles of nitrogen N2. And therefore, I put the 4 and 2 in there because for every 4 moles of ammonia, I make 2 moles of nitrogen. Now, these are exact numbers. This is 3 significant figures. I got it right this time. Do the math, and here's your answer. And remember, balanced chemical equation coefficients tell you coefficients. I'll tell you the molar ratio. Must be Friday. I need a day off tomorrow. Oh, I do get one, and so do you. I hope. All right, let's skip now to number 6. And I have a number of these the same, repeating. Let's do this one. For the following reaction, C3H8 propane, that's the stuff in the white tanks for your barbecue. You react it with 5 moles of oxygen, gives 3 moles of CO2 and 4 moles of water. How many grams of CO2 are made when you react 45.66 grams of C3H8 propane with an excess of oxygen? As soon as you see an excess of one of the reactants or chemicals in a balanced chemical equation problem, you can ignore it. Excess means you've got all the oxygen in the world to react with anything oxygen will react with. So what are we being asked to find? Grams of CO2. What are we given? Grams of propane, C3H8. There is no way you can go from grams of propane in one step to grams of CO2. And I mean one step, not setting up 3 steps together, which some people have learned from high school. I did, but I still like separate them in 3 separate steps. Now, If you look in the lecture folder of Blackboard, you'll see a file called Chem 1211, test number 2, important information. And for test number 2 coming up next Wednesday, that will be given online after class, like we did with test number 1, I will give you the following things. And if we look right here, it says mass calculations for reactions. Mass means grams. So here are my 3 steps. And you should know how to use these. Step number 1, whatever I'm given in grams, I'll convert to moles. And I think you can see it maybe. Kelly, when I'm done with 6, oh, thank you, you can see it. But when we're done with 6, remind me, and I will definitely do 7 and 10 after I give you guys a chance to do 1 first, okay? And if I don't, yell at me. You promise. All right. So when you're given from one, going from a mass of one substance to a mass of another using a balanced chemical equation, you need 3 steps. The first step, whatever you're given in the weight, you convert that to moles. Second step, what you now have in moles, the compound, you convert to moles of the answer of the compound you're trying to get to. And the third step is now you have the moles of the compound you're trying to get to. You convert that to grams. Remember, mass really means grams. And that's how you do it. So let's look and see how you do it. Now, the first step, what's A? We want to convert grams of propane, C3H8, to moles of propane. So here we have grams. We're trying to get the moles. And what do we use? Our good friend, our good buddy, unit analysis. Whatever we're trying to get to goes on top. Whatever we're trying to get rid of, the units go on the bottom. Where do I find a ratio of moles of a compound to grams of a compound? Guess what? Go back to important information. Test number 2, 1 mole of a compound equals the molecular weight of that compound in grams. And the molecular weight of the compound is the sum of all atomic weights in that compound. So first I have to find the molecular weight, and then I can use this relationship. So what's the molecular weight of propane? Well, it's the sum of all atomic weights. And on test number 2, underneath your name, it will say, please use proper significant figures for all calculated answers. And it will also say, use 3 significant figures for all atomic weights. And remember, the atomic weight is found on the periodic table underneath the symbol, the green one I'll give you for test number 2, like test number 1. If we look up carbon, it's 12.0. There are 3 of them. So 3 times 12 is 36.0. Hydrogens, there are 8. 8 times 1.01, the atomic weight of hydrogen. And we get this, we add it up. Don't forget, when you're adding, you get the same number of significant figures to the right of the decimal in your answer that you're adding as the number you're adding that has the fewest. Well, 36.0 has 1 significant figure past the decimal. 8.08 has 2. What's the lower number? Time's up, it's 1. So how do I round this off to 1 past the decimal? Keep the 0, use the 8 to round off, that's 5 or higher. So I'll drop it, increase the 0 to 1. So the correct molecular weight for propane, C3H8, is 44.1. Now, 1 is an exact number, 4 significant, 3 when you're multiplying or dividing, you get the same number of significant figures in your answer as the number that has the fewest, 3. So I have 1.04. Now, at this point, time for a little message from Dr. White, me, in case you forgot, hopefully you didn't. But anyways, when you do multi-step calculations like this 3-step, there's 2 philosophies. One, round off at each step, that's me, or round off at the very end, which is not me. However, I'm not going to force you to do one or the other. You can do either one on a test. And what I will do, like I did in the problem set, is I will calculate it both ways, one rounding off at the end, which is not me, and one rounding off at each step, which is what I do. And either answer is correct. Sometimes they're the same, sometimes they're not. So I round this off to 1.04. Now we have to do the second step. Whatever we have moles of A, propane, we're going to convert to moles of B, the answer we're trying to get, CO2. So I have moles of propane. I have moles of CO2. I use my good buddy, my good friend, unit analysis, put this on top. What I'm trying to get rid of goes underneath. And where do I get these numbers? I come back to my balanced chemical equation. Where do I get a molar relationship between moles of C3H8 and moles of CO2? Up here. When there's no coefficient number there, it's the number 1. 1 mole of propane reacts with 3 moles or 5 moles of oxygen to make 3 moles of CO2, 4 moles of water. So the relationship I'm looking for is 1 mole of propane, C3H8, makes 3 moles of CO2. I'll do that again in slow motion. 1 mole of propane, didn't know Dr. White could go in slow motion, is 3 moles of CO2. And now back at normal speed, put my 1 mole of propane, C3H8, 3 moles of CO2, carbon dioxide. These are exact numbers, 3 significant, not involved, exact numbers. And I get moles of CO2, 3 significant. I round off at each step, but you'll also see the answer at the end for the other way too. Now, third step, whatever I just calculated the moles of, which I'm trying to get to grams, I'll convert moles of B, CO2, to grams of B, CO2. I'm going to use unit analysis, your good buddy, your good friend. Whatever I'm trying to get to goes on top. Whatever I'm trying to get rid of goes underneath. And where do I get a relationship of moles of a compound to grams of a compound? I used to make students memorize this, but I'll give this to you. Important information. Test number 2. 1, I'll also do it on the final. And test 3 and 4, I think. 3 for sure, 4, I don't think you need it. Anyways, 1 mole of an element or 1 mole of a compound equals the molecular weight of that compound. And the molecular weight of that compound is the sum of all atomic weights in that compound. So now I can go back here. Where do I get this relationship? 1 mole of a compound equals the molecular weight of that compound, the molecular weight of CO2, 1 carbon, 12.0, 2 times 16, which I left off here, bad Dr. White, is 32.0. Therefore, the molecular weight, of CO2 is 44.0. Put that in there. 1 is exact number, 3 significant, 3. And notice my answer has 3 significant figures. And also notice when I say both ways, that means you get the same answer, whether you have calculated it and rounded off at each step, in this case, or at the end. I need a tea break after that long problem. All right, I'm going to let you try one, and then we'll go and answer. I'll answer Kelly's questions. All right, let's take a look at this. How many grams hydrogen gas, H2, must you react with an excess of chlorine, Cl2, to make 125.6 grams of HCl? And up here you have the balanced chemical equation. 1 mole of hydrogen reacts with 1 mole of CO of chlorine to make 2 moles of HCl, hydrochloric acid. And so to help you out, I'll tell you this. You'll need 3 steps. Step 1 is grams A to moles A. Step 2, moles A to moles B. Sorry about that. Hold on. Let's see if I can make it smaller so you really can't read it. And step number 3, moles B to grams of B. And it's your turn to have some fun. Have fun, please. I insist. Oh, it warms my heart to look out into the Zoom universe and see all of you people working on these problems. Thank you. What a warm feeling. And you're doing chemistry, and hopefully it's not too painful. If you finish early, please be patient. I try and give everybody time to finish. finish. All right, I think everybody's done. Oh, I see someone's still calculating. So I'll give you another 22.5 seconds. And while I'm waiting, if you're done, since I did the polling, but let's try, give me a thumbs up if you're done. All right, I see everybody's thumbs are up. Did you ever do thumb puppets when you were in first or second grade? Or sock puppets too? Wow, that's an old memory. All right, let's get back to chemistry. Question is, how many grams of hydrogen must you react with an excess of chlorine to make 125 grams of HCl, hydrochloric acid? So what are we being asked to find? Grams of hydrogen. What are we given? Oh, I apologize. I should have given you H equals 1.01, Cl equals 35.0. Bad, Dr. White. All right, you need 3 steps. And those 3 steps are step 1, whatever you're given in grams, mass, you convert to moles. Step 2, whatever you have in moles of A that you convert moles of the answer you're trying to get to. And finally, whatever you have moles now of your answer, you convert to the actual answer grams of B. So step number 1 here, what's A? Well, whatever we're given in weight. So we want to go from grams of HCl, which is A, to moles of HCl, hydrochloric acid. So this is all I have to work with. I want to get to moles of HCl. So I use my good buddy, my good friend, unit analysis, whatever I'm trying to get to, I put on top of this ratio. Whatever I'm trying to get rid of goes underneath. And this is moles of HCl. This is grams of HCl. And where do I get these numbers? 1 mole equals the molecular weight of HCl. Well, here I have them. So if I add them up, that's 36. Actually, this is a 5.51. This is 1 past the decimal, 2, keep the 5, use the 1 to round off. And this would be 1 mole equals the molecular weight of HCl, which is 36.5 grams. Units cancel out. I get the right units. So I now go to my calculator, which I don't have open yet. So let me open it. And now you can all see it. And I put my numbers in and boom, I get this number. Now I'm going to round this off to 3 significant figures, because if you look at the multiplication division, the lowest number of significant figures in that multiplication was 3. So round this off, keep the 3, keep the 4, keep the 6. This is 5 or higher. That means this should be 3.47. Forget about the zeros at the end. That's just the way my spreadsheet is formatted. All right, so now I can go back to my problem, and I've just calculated the moles of A, which in this case HCl, which was 3.47 moles. Now I'm going to calculate it both ways, but I'm going to do on right now, I'm going to be doing rounding off for each step, because that's the way Dr. White does it. And good habits I don't change. And now my second step, moles of A to moles of B. Well, what's A? Moles of HCl. What's B? Whatever we're trying to calculate in grams, first we have to calculate that in moles. And so I have 3.47 moles of HCl. And I want to get to moles of hydrogen. And again, I'll use my good buddy, my good friend, somebody keeping count, because I still am going for the Guinness Book of World Record, saying that the most times in one semester. Use your good buddy, your good friend. Unit analysis, whatever I'm trying to get to goes on top of the ratio. Whatever I'm trying to get rid of, the units go underneath. And I see a couple people. Kelly, you got a question? Go.
I don't know what I'm doing wrong when I multiply 125.6 divide by 36.5.
What do you get?
I get 3.44.
Well, let's go back to the spreadsheet, 125.6. And $125.6, that's the right number, correct?
Yes, 125.6 divided by 36.5.
And that's the
I get a rounded number of 3.44.
All right, I'll tell you what, after class, let's talk, and we'll take a look at your calculator.
Okay.
Because it sounds like it's a calculator problem, because the spreadsheet, I have never seen make a mistake, at least mine. So,
Dr. White, for me, I got the same thing as Kelly.
all right, let me try it again. It's 126.5. I know what I did wrong. 125.6. I reversed it, divided by 36.5. Now I did. Thank you very much, Kelly, for correcting me. And that will happen in a regular classroom. I can do the same thing once in a while. And by the way, let me first of all come back to here. What if you did do that like I did? I transposed these two numbers. And let me first correct this. Again, Kelly, thank you very much for letting me know. I appreciate it. And I'm sure your colleagues appreciate it. And whoever I forgot also confirmed that. Thank you. Now, what if you had put down 33.46, which is wrong, and you did the rest of your calculations and you got the wrong answer? And that happens. And what should you be doing? Showing your work. If I can see the work like this, I can track down where the error is. And then if it's a math error like I just made, if it's a 10-point problem, instead of giving you 0, I will give you 9 points. So anyways, thank you very much. Let's change this to 4 and let's continue on. Now, we're going moles of HCl to moles of hydrogen. Whatever we're trying to get to goes on top. Whatever units we're trying to get to goes underneath. Where do we get a ratio of moles of hydrogen to moles of HCl? You come up to the balanced chemical equation. And what this tells me, coefficient is 1. 1 mole of hydrogen makes 2 moles of HCl. 1 mole of hydrogen makes 2 moles of HCl. That's from the coefficients of a balanced chemical equation, which gives you molar ratios. And therefore, I look again, 1 mole of hydrogen makes 2 moles of HCl. 1 mole of hydrogen makes 2 moles of HCl. These are exact numbers. Before I go, moles of HCl divided by moles of HCl. Remember, anything divided by itself equals number 1, meaning it cancels out. And now I can go to my spreadsheet and keep an eye on me. I made one mistake already. And notice I get 1.72. And now I'll go back, and it should be 3 significant figures. Dr. White gets in that rut. 1.72 moles of hydrogen. Am I done? No, because I'm trying to get 2 grams of hydrogen. And now I'll do step number 3, which is whatever I just calculated the moles of, I'll convert to grams of that compound. So in this problem, that would be moles of hydrogen, 2 grams of hydrogen. And therefore, I have 1.72 moles of hydrogen, which I calculated here in step 2. And if I had a ratio, I'm trying to get to grams of hydrogen. And how do you proceed? You use your good buddy, your good friend, unit analysis. Whatever I'm trying to get to goes on top. Whatever I'm trying to get rid of goes underneath. Oops. And where do I get this relationship? You look at test number 2, important information, which I used to make students memorize, but I'm giving it to you. 1 mole of a compound equals the molecular weight of that compound in grams. The molecular weight of that compound equals the sum of all atomic weights. So what I need here is the atomic weight of hydrogen. That's the sum or the molecular weight of hydrogen gas. That's 2 hydrogens. The atomic weight of hydrogen is 1.01. And this is an exact number, so it would be 2.02. and I've got this backwards. Somebody should have caught me. My good friend, unit analysis, just showed me. Now, and I see this wouldn't have canceled out. So that's how I knew I made a mistake. And this is now 2.02 per 1. This is an exact number. 3 significant figures, 3 significant figures. My answer should be 3 significant figures. And so I'll now go to my spreadsheet. And if you notice, there's a slight difference. In column E, the last number, I should round off the 3 significant figures, keep the 3, keep the 4, keep the 7. This is 5 or greater. That becomes 3.48. In this one, you round off and it's 4, so you drop it 3.47. Now, which is the correct answer on my test? Either one of those. And there's how you do it. Oh my goodness. If I look at the clock, it's time for our break. When we come back, Kelly, yes, I will do your questions. I don't forget when students ask questions. If I do, remind me. Say, you promise. I'll see you in 5 minutes at 9:55. I'm going to get up and stretch. I'll see you in 5. Time to come back. All right, hope we all had a nice break. I got to stretch. Since I had some problems last November when I hurt my back, also a problem I was having with almost a year ago with my leg. I found after having physical therapy that helped me out greatly. Get up and do some certain leg stretches that I need to do, and it makes me feel more comfortable, which is a good thing. All right, now, special requests. One of your colleagues asked, can I do, I believe, hold on, let me refresh, 7 and 10, and the answer is yes. So let's go back and look at number 7. Let's move this up here. Let's move this over here. And here we have this balanced chemical equation. We're asked how many grams of carbon monoxide, CO, are made when you react this amount of ferric oxide, otherwise known as rust, with an excess of carbon. So you need 3 steps. First step, what do? You take grams of ferric oxide and you want to go to moles, and you use 1 mole equals a molecular weight. I don't know why I have gray area here. But anyways, you have iron, the 3 significant figures. And I see a comment or question. Did I do the addition wrong? I might have.
I got 159.6.
Guess what? I did the addition wrong. So that should be 159.6. End of the semester, I'll go back and correct this. Thank you.
Okay, that's the question I had. So that answers everything.
That's going to change everything. And I'm not going to do the math right now, but everybody change this to 159.6. And this will change. This will still be the same, but this number will change. Did I get CO correct? Come on, go away at the bottom. And I did. So anyways, the numbers will be different, but the way it's set up is correct. Again, thank you very much for correcting my error. And the other one was 10?
Yes, I had a question of, I think I got.
Which one did I make my mistake?
When I did part 2, I got a different calculation. I didn't get 18.4.
What'd you get?
I think I got 6.12.
Which would change the answer. Let's find out real quick on this one. Oh, Dr. White made a lot of mistakes on this. So that was number 7 and number 10. I'm going to have to go back and redo this. All right. That would be 10.2 times 3 divided by 5. And you're right. Oh, I'm going home. Wait, I am home. So, wrong thing. This should be 6.3. So the correct answer here would be 6.3.
Is it 6.3 or 6.12?
What did I get? Hold on.
6.12.
Let me look at Ah. You convert as 10.2 times 3 divided by 5, and I think I know where I made my mistake on my calculator again. Now it should be, ah. Is that what you got? What did you get, Kelly?
Oh, I can't see
What number did you
the
get?
spreadsheet. Oh, I got 6.12.
All right, let's try this again. It's 10.5, correct?
It's 10.2.
Oh,
Is it
okay. Time
10.2 times
times
3 divided by 5.
6.12. You got the right answer. So this should be, the correct answer should be 6.12, not this one. Kelly, I'm gonna let you take over and finish the rest of the day. I'm just gonna be a student, so I don't have to worry about making any more mistakes. Bad Dr. White. Bad Dr. White. I shouldn't be nice. Don't beat myself up too badly. Thank you very much for pointing that out. And I will correct that sometime this weekend. Doesn't that feel good? You're learning this stuff better than Dr. White. But anyways, all right, let's go to the last part of that problem set. That's the only one I gave you. Ah. All right, let's look at the one I just made a mistake on. Yes, Kelly, great job. Thank you. Everybody, let's give Kelly a hand of approval. Thank you. And let's just all boo at Dr. White. Boo. Not thank you. All right, let's look at number 10. We'll also do one, and that is for the following reaction, C3H8, propane reacting with oxygen. 5 moles makes 3 moles of CO2 and 4 moles of water. How many moles of CO2 are made when you react 2.35 moles of C3H8 with 10.2 moles of O2? And this is called limiting reactants. You need 2 steps. You're trying to find the moles of a product, and you're given both the moles of propane, C3H8, and oxygen. And if you look at important information, test number 2, you see I have limiting reactants, and there's a little note there, beware of Dr. White, he makes mistakes on a problem set. But anyways, for limiting reactants, determine the number of moles of product produced using the number of moles of each reactant. So you do the calculation, in this case, 2 reactants, 2 calculations. You go from moles of reactant to moles of the product, and the lower number is the answer. So if we go back here, the first one is going from moles of propane to moles of CO2. Use your good buddy, your good friend, unit analysis. Whatever you're trying to get to goes on top. Whatever you're trying to get rid of goes underneath. Where do you get these numbers? from the balanced chemical equation, 1 mole of C3H8 propane makes 3 moles of CO2. These are exact numbers. This one I got right, and it's not the answer. I got that wrong. And then the second one, you use oxygen. And when you do the math correctly, first of all, you want to go from moles of oxygen to moles of CO2. Whatever you're trying to get to, units go on top of the ratio. Whatever you're trying to get rid of, units go below the ratio. Where do you get those numbers? From the balanced chemical equation. We're looking for a ratio of moles of oxygen to moles of CO2. For every 5 moles of oxygen, I make 3 moles of CO2. For every 5 moles of oxygen, I make 3 moles of CO2, which is where I get for every 5 moles of oxygen, I make 3 moles of CO2. And the number here is wrong. It was 6 point whatever, and this would be the correct answer. Let me go back and look at my spreadsheet. That'd be 6.12. So for that problem, the correct answer would be this one, 6.02 or 12, whatever, hold on. 6.12. Well, now Dr. White has to redeem himself. So I'm going to do another problem, and everybody make sure I do it right too, because don't tell anybody, but I make mistakes too. Do I have time? Oh, yes, I do. Are you ready for another Dr. White story? All right. I might have mentioned it in class. When you go for your PhD in chemistry, at least at Michigan State, and you go for your PhD, after you've written your thesis and it's been read by your faculty members, you have your defense of your thesis. And then if you pass that, and that's a couple hour fun, no, not fun at all. It's high stress time, like the most high stress almost I've ever been in my life, because now you're defending a couple years of your work to get a PhD. And what you do is you're in a, with your research advisor, mine, I was quite fortunate, lucky to have Dr. Roosh as my research advisor. I was in his group, and your other members of your research advisor team, which were 3 other chemistry professors, another organic, and 2 more organic, and an inorganic professor. And they had all read your thesis. My faculty advisor read it at least twice, probably more, because he would say, no, you got to correct this and this. And once he agreed and signed off on that, I proofed it at least 10 times, including reading it backwards, looking for mistakes. And in my research group, I had a couple other graduate students proof it too. Well, after I got my PhD, yay, I passed my orals. Before I left, Dr. Roosh called me into his office and said, I have some advice for you. I said, what? He says, after today, never open your thesis again. I said, what? He said, don't. You're going to find mistakes. And about 2 years later, I happened to have it at that time on my coffee table in my apartment. Friend came over. Oh, it's your thesis. Can I look? I said, sure. And he showed, oh, what's this? And all of a sudden, I see a minor mistake. And about a year and a half later, the same thing happened. Somebody showed me, and I think it was very minor, like a spelling error or something like that. And here we had proofed it so many different people, and you still find mistakes. But anyways, that's my story. But as I say, I don't walk on water unless it's frozen. Even then, I stay off it. All right. It's time for you to do one and for me to find out if I can still do it right. And here's the question. How many moles of HCl are made if you react 5.14 moles of hydrogen with 2.76 moles of chlorine? And I'll give you a hint. You need 2 steps. And the first step, calculate moles of product. This is given to you. Step 1, calculate moles of product for each reactant. And step 2, lower number is your answer. And there you go. And when you're done, give me a thumbs up. I see 1 thumbs up. Oh, I see another one. I see a lot of them starting to pop up. I see you hurry up. All right, looks like everybody's done. Let's do this. Oh, by the way, Kelly and everybody else, keep an eye on me. Make sure I don't make any mistakes. Thank you. All right, how do we do this? You need 2 steps. And what do you do for each reactant? First one, we have 5. What are we trying to find? Moles of HCl. What are we given? 5.14 moles of hydrogen. And we're given 2.76 moles of chlorine. So we're trying to find this. We need 2 steps. And the first step is take each reactant, in this case 5.4114. Wow, I'm going to have to reboot my brain. Moles of hydrogen, and we want to get to moles of the product, in this case HCl. So I'm going to use my good buddy, my good friend, unit analysis. Whatever I'm trying to get to goes on top. Whatever I'm trying to get rid of goes underneath. And where do I get these numbers? I look up here at my balanced chemical equation. Where do I get a relationship between hydrogen and HCl, hydrochloric acid? 1 mole of hydrogen, remember when there's no coefficient, it's the number 1, makes 2 moles of HCl. 1 mole of hydrogen makes 2 moles of HCl. So I have 1 mole of hydrogen makes 2 moles of that. And if I go to my calculator, keep an eye on Dr. White, he makes mistakes. About to make a mistake right now. And it's 5.14. And if I round that off to 3 significant figures, that's 10.3. So I'll go back. And here I would get 10.3 moles. Now the other reactant is chlorine. I have 2.76 moles of chlorine. And we want to get to moles of HCl. And now, when I use my good buddy, my good friend, unit analysis, whatever I'm trying to get to goes on top of the ratio. Whatever I'm trying to get rid of goes underneath. And when I write that in, I have moles of HCl per moles chlorine. Where do I get these ratios? I come back up to the balanced chemical equation. Remember, when there's no coefficient, it's the number 1. So I know 1 mole of chlorine makes 2 moles of HCl. 1 mole of chlorine makes 2 moles of HCl. So 1 mole of chlorine makes 2 moles of HCl. And I'm going to go to my calculator again. Keep an eye on me. That includes Kelly. I do the math. I get 5.52. Did I get that right? Oh, and I'll come back here. Aren't you glad I have a sense of humor? I am. Plus, if I'm making mistakes, it's always good to have someone back me up to make sure I'm not. And you get 5.52. And I see I have someone with a question or comment. And do you have another question? Go for
it. I'm afraid to ask. I want to know for the first part where it says 5.14 times 2. Since the 2 and the 1 are exact numbers, when would we put like 10.38 or 10.28?
Well, it matters on what's the number right here. If I put 5 points, a good question. Remember, Kelly, and everybody else, Dr. White's going to get serious now. There's no such thing as a dumb question. And there are no limits to how many questions you can ask in my class, ever. and outside my class. Now, I may have to go on to another, if I can't answer your question in 1 or 2 tries, I may say, see me after class or see me in my office hour or after lab, but I will do the best of my knowledge to answer questions. And do you want to know a secret? If you ask a question, I'll bet about 60% of the class has a similar question. So you're not only helping yourself out, you're doing a good deed for the rest of the class. Never, ever be concerned about asking more than one question in my class. Got it? All right. So if I put 5.140, now this is 4 significant figures. So we'd have to have an answer that would then be 4 significant. So that's just the nature of the beast. Ooh, I haven't used that in ages. Probably won't again for a while, but that's how you do that. Now, one of the secrets, which I think I told you, having been brought up with a slide rule before calculators were available cheaply, anybody from my generation is usually stuck in 3 significant figures. And I've done calculations worth hundreds of thousands of dollars, and it works. All right. So we're still not done yet. What's the correct answer for this problem? How many moles of HCl? Now we do steps 2. The lower of these 2 numbers is the answer, and hopefully you all pick. This is the lower one, therefore, this is the answer. Quick, keep an eye on me, make sure I calculated it correctly and wrote it correctly. And that's how you do it. Any questions about anything I've covered this morning so far?
I just have one more question on 7. On number 7.
All right, hold on while I get back there. All right, there's number 7. Let me move some of this out of the way. All right, what was the question other than the mistake I made in my addition?
Well, in my problem, I did 159.6, but I know typically when we do atomic weight, we do 3 significant figures. So how would that work in terms of a test?
Hold on. Let's talk about something. It's a good point. You only look at the number when you do an addition here, the number of significant figures. Ah, now I know where I made my mistake, and I didn't make a mistake. This should have been 112. Okay, so technically I got it right, but I got it wrong. Everybody with me on that? Let's take a look. And who asked that question just now? Who? I didn't catch. Who was that?
Justin.
Justin, thank you. All right, if we look at that, and I'm going to do this on the whiteboard. And let me just copy this down somewhere. All right, what Justin pointed out was a good point and showed me where I made my mistake. If you're getting Fe2O3, it's 2 iron and 3 oxygen, and each iron is 55.8. And this should be to 3 significant figures, exact number, 3 significant, 112. Now this is 3 times 16.0 into 3 significant figures, that's 48.0. Now, when you add them up, you don't look at this as 3 significant and 3 significant. My answer should be, now we do different rules for addition. And this would be this. Notice here, this has none past the decimal. This has 1, so the correct answer there would be 160, which would be 2. And now I understand why I put gray area. Okay, this really should be 160, which would mean I got this wrong. This should be 2 significant figures. So I messed this whole thing up. Hopefully that helps you out. But the key thing is, and it took me a while to wrap my brain around it, when you're adding 2 things together, you only look at past the right of the decimal for significant figures of your answer. And now I know why I put gray area. That's one of those things where you round off 160.0 to 160. And I won't do that ever on a test where the rounding off will be very obvious, okay? All right, any other questions? Going once, going twice, going 3 times, time for a water break? And guess what time it is? It's lab time. I hope you're all ready for a really colorful, exciting lab, including Dr. White's going to have a show and tell. Ooh, that reminds me, when I was in 7th grade, show and tell or giving a report in school, my teachers were afraid of me. They were afraid, what the heck is Dr. White going to do? At that time, I wasn't Dr. White, obviously. I remember in 7th grade, it was give a report on anything you wanted to. And the English instructor, oh, was she mad at me after I gave my report? Because I gave it on something I was interested in at the time, plain polarized light. Yeah, that was 7th grade, and I was already doing science. And she didn't understand one word of what I did. It was a good report. I did a good one, but she was mad because she was not a science person. All right, let's talk about today's lab. And let me just get it up. Okay. Now, important thing in chemistry and science or in life is, if you have something, is it pure? And today, show and tell, food coloring. That comes in this cute little bottle. Isn't that cute? And it's got a liquid in there that you put in your food. I'm not going to do it because it stains skin real easy and other things too. But is the liquid in here? And notice my favorite color, red. Isn't that cute though? But anyways, I wonder why they put a pointed top on. Hopefully you wear your safety glasses so they don't poke your eye out. But anyways, how do you know the stuff inside? Is this pure or is it a mixture of things? And that's an important question to be able to answer. And how do we do that? We use what's called chromatography. Now, there are different types of chromatography. How many of you have ever seen the CSI programs, which Dr. White doesn't watch because half the stuff is pseudo chemistry, not real chemistry, and that makes me upset, so I don't watch them. But where they inject something either by manually or machine, puts it in another machine, and after a while they see on the computer screen these lines. They say, oh, this chemical and this one was in that sample that the detective brought, and now we can find out who we can convict for whatever heinous crime you want to put in what they did. And that's called gas chromatography, separating components of a mixture into individual components and isolating and identify them. Now, the oldest of the chromatography is called paper chromatography. That's where you use paper to see if a mixture, like the red food coloring, is it one substance or a mixture of more than one. Hang in there, why? Everybody see lit on your screen? Thank you. All right, this is from Wikipedia. I've mentioned this, but I'll mention again. For many years now, Wikipedia has been so heavily pleased in the chemistry area. I don't know about the other stuff, but the chemistry area is so heavily pleased by PhD chemists like myself. And yes, I have requested changes and they're made because of my credentials, that I haven't seen in a couple of years any major, even somewhat minor mistake in chemistry posts in Wikipedia. Now, here they talk about paper chromatography, and chrome talks about color, and paper, you're using a piece of paper, and you have some container with a solvent. Now, how many of you have ever seen, if you take a paper towel and you put it down in a little puddle of water, you know how it sort of absorbs the water and you see it going, moving along the paper? Well, if you hang paper in a solvent, the solvent will go up the paper. Now, if you have put a sample of something with different mixtures, you can, with the right solvent, or sometimes if you use solvent pairs, separate them into different spots. And that tells you whether, if you only see one spot here, it's pure. If you see, like this case, 3 spots, well, there are 3 components, 3 chemicals, and whatever you put on your piece of paper for your paper chromatography. Now, you never let the solvent front, the liquid, go all the way to the top. You stop it before the top. And the distance from where you put the original dot of what you were measuring to the top of the, how high the solvent went, is called the RF value, which you could calculate for that. And I forgot what R stand for in RF value. Hold on. Oh, retention factor. I've been calling it RF value and I forgot what that was. This will never be on a test. But anyways, that's paper chromatography. And today's lab, if you were in the lab, and let me just check real quick. Thumbs up, people. You see the lab? Thank you. You would be using chromatography. By the way, those chemists in CSI are analytical chemists, and those are analytical chemists are chemists who use analytical chemistry to analyze things and create analytical methods that do that. And I've used those when I worked in the lab. I was an analytical chemist, but organic chemists use those methods to help identify compounds. And one of the oldest of all analytical methods is paper chromatography. And what you do is you take a special chromatography paper. You just can't take a piece of typing paper because that's treated paper to begin with. You put it in a beaker with some solvent. Then you watch the solvent go up. That's called the solvent front. And different compounds move at different distances in the paper because of intermolecular forces. Intermolecular means between 2 molecules, the paper, the solvent, and the compound. And part of that is hydrogen bonding and other factors too. And as I said, I talked about the RF value, retention factor, which we won't do in this lab. In this lab, you're going to determine are certain food coloring products like this, or not to cheat you out, like blue or like yellow, and there's also green there I'm not going to take out right now, are they pure? If you look at the yellow, it almost looks like it's red, but the red looks darker red. If you haven't guessed, red is my favorite color. This is above my monitor. So is this. Oh, you're learning all about Dr. White's private red fetish. Oops. But anyways, I like the color red. So in these food colorings, are they pure? Is this pure red material that makes your frosting in your cake red or whatever else you're doing, the food color? Have you ever had velvet cake? That's a big thing down south. But anyways, that's what we're going to do today. And let's look if you are actually in a lab, and we do this in a lab. We use filter paper, which is sort of cheap, but it works sort of. And you use a pencil, not a pen, to draw a line at the bottom of your strip of paper about a ½ inch up. And then you wear gloves. Whenever we work at COD, all students and faculty in a lab have to wear gloves all the time. We issued this, started doing this a couple of years ago, and you have to wear safety goggles. And you take a toothpick. In the lab, when you do it in a research lab, you just use a little glass, very thin glass tubing called a capillary tube. And you put a small drop of whatever you're analyzing on that line, separated, and you let it dry. And then you put it in a beaker with some water, or step 4, put in the filter paper and wait until it goes almost to the top. And the level of the water should always be below the level of your line, but close to it. You put a cover on the top of the beaker. And in the lab, we use either plastic wrap or aluminum foil. And then you wait about 10 minutes and you see the lines go, stuff moving, and then you observe it. Now, and you clean up afterward. Now, when you're doing that in the lab, you look how many dots you see, just like you saw on the slide. In real life, they don't look that clean like you saw in the picture. Now, since you're not going to do it in real life, guess what? I found a nice YouTube video of this, and they use the top color in the video is red, next green, then blue, yellow, and I don't have it in my little box of colors. They also do black. I've never seen black food coloring. I'm sure it's out there. So let's go, and I'm going to show you. Thumbs up, people. Do you see YouTube? Thank you. All right. All right, here's what it would look like. There's the solvent front right here. Now, in real life, it's never this pretty. See how this is angling off? Each one of these numbers you now see on your screen correspond to what I call a dot. Even though this has a trail, this is this one compound. This would be another one. And you wait until it goes almost all the way to the top and you take it out. Now, let's look at the second sample right here. E104 and E142, why they use those numbers, I don't know, tell you they have two different substances in the dye that was used for the second one, which if we look, when we go back, I'll look at the second one, and that's that color. So this would be for the second one, 2 dots. Is it pure? No, because they're two substances. Second one was green. So everybody, for green, how many spots, numbers, dots in the video? And the answer would be 2. You've got to go back and look at it for red, blue, and yellow. And remember, here's the first top one was red. Second one, which I just did for you, is green. Next one, blue, then yellow and black. And that's today's lab. And you'll answer these questions. And I also have a fun one. Number 4 is the sheriff of DuPage County needs to know if the key evidence a colored liquid is one pure substance or a mixture of substances in order to convict a terrible person of a heinous crime. I'll let you fill in what heinous crime you want to convict that person of, and you will test how will you test the liquid to determine if the colored liquid is one or more as a substance or mixture of substance. Please note that your answer will be presented in a court of law as evidence. So the stress is on you. Make sure you do that right, because we want to convict that terrible person of that heinous crime. I don't know, I'll let you fill in the blank for whatever heinous crime you're thinking about right now. And that's today's lab. Thank you, Danny. I'll remember that. No, I'm just kidding. Actually, you're wrong. That was not a heinous crime. That was a good deed. And Dr. White thanks her. Don't tell the Thursday people. And with that, I look at the clock and I'm done for today. And it's time for Dr. White's famous goodbye. So I better do it. Gang gesund. Goodbye. I'm done for today. I'll stick around if anybody has any questions. It is nice to laugh on a Friday and a Thursday and a Saturday and a Monday, Tuesday, and Wednesday. And I will see you on Monday. Remember, do the practice problems if you haven't, because test number 2 is coming up on Wednesday. I'll be giving you the password after class. With that, I'll do it again. Gang gesund. Goodbye.